Department of Collegiate Education, Digital Learning. Welcome to the video session of BSc 3rd semester Electricity and Magnetism DC Circuit Analysis, presented by Savita S. So, contents of this video are overview, statement of superposition theorem, explanation with a solved example. Overview. So, superposition theorem is applicable to complex network having several input sources. Only when there are multiple input sources, superposition theorem is applicable. It is derived from superposition principle and applicable to linear systems. So, principle of superposition, wherein one thing is taken at a time, aids in simplifying the circuit analysis. So, statement: in a network with two or more sources, the current or voltage for any component is the algebraic sum of the effects produced by each source acting separately. So, when we have two or more sources, current or voltage across any one component is the algebraic sum of effects produced by each source acting separately. So, we will see how this theorem can be applied. So, the method of application involves the following steps. All sources except one under consideration are removed. Only one source is taken at a time. Current and voltage across the required resistor is calculated. The process is repeated for all other sources taken one at a time. Finally, the algebraic sum of I and V across a resistor due to different sources is taken. So, we will take a numerical example and learn how exactly this can be done. So, for example, this is a network having two sources. So, there are three resistances. If you want current and voltage across any resistor, either 5K, 1K or 100 ohms, then how it can be done using superposition theorem, that is what we are going to discuss now. So, two sources are there. So, we will remove the second source. Let us say 5 volts if we remove, then we will have a circuit like this with only single source, 100 ohms. This source will be supplying the current, say I1. This is called the main current, that when it reaches this point gets divided into two branch currents, I2 and I3. So, we will find out what is I1, I2 and I3 with a single source. Next, we will remove the first source and have the second source alone. Now, the circuit main current itself has changed. So, I3 will be the main current now. That gets, when it reaches here, divides into I1 and I2. So, in this case, what is I3, what is I1 and I2 we will find out. Suppose we want the current and voltage across 5 kilo ohm, then we will find out what is the current in the first circuit, that is I2 from the first circuit, then I2 from the second circuit. We will add these two, that is the current when both the sources are present. So, when both the sources are present, let us say I is the current, that I is equal to I2 from figure 1 plus I2 from figure 2. So, let us see how we can calculate the currents. So, let us take two simple circuits like this. So, the same whatever we discussed earlier, same, so network is taken here. So, we will take one source at a time, find out what is the main current and branch current. So, to find the main current, we need to know the total resistance. So, total resistance we can find out from the circuit, effective resistance. So, 10 volt is supplying a current, 10 volt is supplying a current equal to I1. So, that I1 when it reaches here divides into two branches, I2 and I3. So, 5 and 1K are in parallel here. Whenever current divides, that is called as a parallel combination. Whenever current is the same, it is series combination. So, 5 and 1K are in parallel. So, the effective resistance is 5 into 1 divided by 5 plus 1. This combination of 5K, 1K parallel combination is in series with 100 ohms. So, plus 100 So the effective resistance is 933 ohms. So main current is equal to EMF divided by total EMF by total resistance. So EMF is 10 volts and total resistance is 933, which is equal to 10.7 milliamps. So this is the main current. So I1 is the main current. Next is I2 and I3 branch currents. To find branch current, we use branch current formula. Branch current formula is main current into resistance of the other branch divided by sum of the resistances. So if these are the two branches, 5K and 1K are the two branches. Suppose we want current I2, that is current flowing through 5K, then we take main current, that is 10.7 into resistance of the other branch. If we want current through 5K, we have to take the resistance of the other branch, that is 1K in the numerator, divided by sum of the resistance in the denominator. 5K plus 1K is 6K. So that is equal to 1.78 milliamps. Similarly I3, if you want I3, that is current through 1K, then main current into resistance of the other branch. If you want current through 1K, we should take the other branch resistance in the numerator divided by sum of the resistances. So that will be equal to 8.9 milliamps. So we know all the currents in the branches here in the first circuit. Now we will come to the second circuit. In the second circuit also a similar kind of thing happens. So first we have to find the main current. For finding the main current, we have to find the effective resistance. Effective resistance is equal to, in this case, main current is I3 because the current supplied by this battery. So that current is getting divided into I1 and I2 here. So the total resistance is parallel combination of 105 in series with 1K. So 5000 into 100 divided by 5000 plus 100 plus 1000 is equal to, this is the effective resistance. These two resistances which are in parallel, that parallel combination is in series with the 1K. So main current is equal to total EMF divided by total resistance. So 5 divided by 1098, which is equal to 4.6 milliamps. So I2 and I1 are branch currents. Now we will use branch current formula. So I2 is equal to 4.6 milliamps, that is main current into, if we want current through 5 kilo ohm, then we should take the second branch as in the numerator, that is 4.6 into 100 divided by 5100. Sum of the resistances is 5K plus 100 is 5100 is equal to 0.09 milliamps. Similarly I1 is equal to 4.6, main current is 4.6 milliamps into resistance of the other branch divided by sum of the resistance. So if you want I1, we should take the resistance of the other branch in the numerator. So we have found all the branches by taking branch currents by taking one source at a time. Now to find the total current and total voltage. Suppose we want to know what is the total current through 5 kilo ohm, then current from the first figure plus current from the second figure is added to get the total current. This is the current that is present when both the sources are there in the circuit. Total voltage across 5 kilo ohm resistor is V is equal to total current into the resistance will give you 9.35 volts. So the superposition theorem is used whenever there are multiple sources and the circuit should be linear. That means there are no non-linear devices like transistors, field effect transistors or such kind of devices are not there, then only superposition theorem can be applied. Thank you.